Legacy Sabers, Marsh here. So today we're going to talk about how to convert between other number systems. So this is the decimal, binary, and hexadecimal conversions. Talking about how to convert between each of them. So what have we already looked at? Well, we've looked at what makes a number system. We understand binary numbers, and we have converted between decimal and binary. Now we're going to add another number system, which is called hexadecimal. Very commonly, this is used to describe locations in memory and also in colors for HTML. This is a base 16 number system. It has the following shapes in its number system: a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F. So A is what we would call 10, 11, 12, 13, 14, and 15. Now, being that this is a base 16 number system, this is the power of 16. So, kind of like how binary was 1, 2, 4. This one is 1, 16, 256. This is 16 squared, okay? So that means it's going to be a lot bigger numbers can be represented in hexadecimal, much smaller, because of 256 being the third bit of hexadecimal. Now, how do you go from our number system to hexadecimal? What you're going to want to do is find the largest power of 16 that you can divide into that number. We're going to divide that number by the largest power of 16. The number before the decimal is the number for the largest place value. Then we're going to figure out what's left behind and repeat the process. Now, let's talk about it. Convert the decimal number 98 to its hexadecimal number. So, I need to figure out, of my powers of 16, 116 and 256, what's the biggest number that can go into 98? Well, 16, right? So I want to know, how many times does 16 divide into 98? So I'm going to go 98 divided by 16, aka Marsh is totally going to use a calculator. So 98 divided by 16 is 6.125. Now, I don't care about that 0.125. I care about how many whole 16s can go into 98. So I know that this value, the 16 place value, is going to have a 6 in it. Now, I need to know how many ones need to be in here. Now, to figure that out, what I'm going to do is I'm going to figure out how many 16s is. So I'm going to take 16 times 6, which I get 96 for that. And I'm going to see how far is 96 from 98? Well, it's 2. So I need 2 ones to make 98 in hexadecimal. So for hexadecimal's version of 98 is 62. Now, don't call this 62 because 62 is different than 62 in hexadecimal, okay? So be very, very careful to not call that 62. Let's try one more. I'm going to convert the decimal number 243 to its hexadecimal. So again, gotta figure out what power of 16 works best. 16 is the biggest power, so I'm going to figure out how many times does 16 divide into 243. So 243 divided by 16 is 15 and some change. Now I can't put the number 15 here because 15 is 2 shapes. So then I got to think, all right, so well, we said A stood for 10, B stood for 11, C stood for 12, D stood for 13, E stood for 14, and F stood for 15. So I'm going to put a F for my 16 because that's me saying there are 15 16s in my number. So now I got to figure out how much is left behind. So I'm going to go 15 times 16. That is 240. which gives me a leftover of 3. So I need 3 ones to continue to finish my number. So the hexadecimal equivalent of 243 is F3. A lot of math, I know, but it's not hard math. It's pretty much grade school math. What if I want to go the other way? You're like, whoa, Marsh, no, this is too much. It's not bad. So remember, place value, right? So this 5 and this A. This 5 represents how many 16s is in my number, and this A represents how many 1s are in my number. So let's figure out, what does 5 16s value? So that's 5 times 16, that's 80. So this is 80 plus how many 1s does A represent? Now, what does A stand for? A stands for 10. So I'm going to go 10 times 1, aka 10. So 5A is the decimal equivalent for 90. Not hard. I would say going one way is easier than the other. So I would say going to decimal from hexadecimal is much easier than going from decimal to hexadecimal. Now, sometimes you're going to want to go between all of the systems. I know, so much fun, right? So let's first go to binary. So we're going to go from 67 into binary. So I got to figure out what's the highest power of binary that goes into a 67. So I'm going to write my binary up here. I got 1, 2, 4, 8, 16, 32, 64, right? Would be the highest number. And I'm going to make this into a byte, aka I want 8 letters or 8 numbers. So 1, 2, 3, 4, 5, 6, 7. That'd be 128. So I'm going to put a 0 to match that 128. I have 164 in there, right? So then I would have 3 left over. So I don't need any 32s. I don't need any 16s. I don't need any 8s. I don't need any 4s, but I need a 2 and I need a 1. So that would give me 67 for my decimal. Now, going to hexadecimal, there's 2 ways to accomplish said task. You can look at the binary, or you can look at the decimal. Let's look at decimal to hexadecimal, and then the second row I'll show you the next one, okay? So I need to figure out what's the highest power of 16 that can go into 67. Well, 16, right? So 67 divided by 16 is a 4. And then what's left behind? So I'm going to go 16 times 4. That's 64. I need 3 more 1s to make 67. So hexadecimal equivalent would be 43. Let's go from binary to decimal. So I'm going to put my labels here, 2, 4, 8, 16, 32. So I have 1, 1, 116, and 132. Let's go ahead and add. So I'm going to do 32 plus 16 plus 1. My decimal equivalent is 49. Now, how do you go from binary to hexadecimal? Well, here's the cool thing. I'm going to split this into groups of 4, because groups of 4 will give me a 16. And then I'm going to consider this each from 1, 2, 4, and 8. So this represents 1 in binary, right? We're not looking at this half, just at this half. That's going to represent how many 1s I need for my hexadecimal. Then I look at the next one. I need to represent this as 1, 2, 4, and 8. Well, this would represent 3, right? The number 3. So I need 3 16s. Shortcut, right? Pretty fast when you get from binary. Super cool as well. Now, let's go from hexadecimal to decimal. So this tells me I need 1, and 16, right? So 3/16. D stood for what though? So we got to go up here again. And this is constantly what I write. B is 11, C is 12, D is 13. So there's 13 ones here and 16 threes, or 3/16, excuse me. So 48 plus 13 is 61. So that's my decimal. Now I need to go to get my binary. So what I can do is exactly the same thing. So I need to represent 3 on the first half. So that would be 1, 1, 0, 0. And we need to represent 13 on the other side. Well, if I'm looking at 8, 4, 2, and 1, that would be an 8 and a 4 and a 1, right? That would be 13. So I need an 8, a 4, no 2s, and a 1. So right here, this entire binary number represents 61. Strange, I know. Kind of a fast and you feel like you're kind of cheating, but nevertheless, super cool. Now, what you could do if you are not comfortable with the splitting up, you could always get to the decimal and then do our conversions like we were doing earlier as well. Depending on what works for you, depending on where you are in your comfortability with math is probably where it's going to go. That's the end of this video. I will see you later, Sabers.